So I will briefly first introduce myself and will give the role to Cara. I'm Minghui Zheng. Currently, I'm an associate professor at Texas A&M University, College Station, United States. And my area is that I mainly utilize the robotic arms working collaboratively with human to do some electronic waste recycling, trying to achieve the manufacturing sustainability and also environmental sustainability. And very nice to see everyone. Looking forward to more detailed and in-depth discussion with everyone here.
Great, thank you, Minghui. My name is Cara Tobin. I'm part of a venture capital group that's based in Boston, although I'm based in Switzerland, and I teach and do some research at the Swiss Federal Institute of Technology in Lausanne. APFL, as you can see in the background. So the venture capital group that we work with really focuses on clean tech, climate tech, and it has since 2018. We have a mandate of funding only innovations that can reduce 2.5 gigatons of CO2 equivalent emissions by 2050. So when the technology is at scale. So I'm very excited to see what's happening in the robotics field, which is not my area of expertise. I'm an environmental engineer, but I am technical. So it would be really interesting to see, for me, to hear from you, especially the startups, how you are an enabler to reduce emissions or to do anything within the aspect of climate. So I'm very excited about the panelists today. And so Minghui and I will try to, get the conversation rolling. And I think we really appreciate any comments and we'll try to address them whenever they come up. Thank you. So I think we wanted to then go into having the startups introduce themselves one by one, and perhaps it's easiest to do this in alphabetical order. So I think Mollie, Hendrik, is that correct? You're first, ARC. Yeah, if we could do that in the order of the letters, it'd be helpful. And what I was hoping, by the way, is if you could do some things, which is to explain the challenge you're working on, which climate problem that you're tackling, and why we need to tackle this. So it's just I'll put this in the chat so you don't forget, but basically 3 things: the challenge, the problem, and how you're planning to tackle it. So yeah, I will let you go on, and I will be taking notes. Thank you.
Yeah, thank you for the introduction. Can you hear me okay? Okay, yeah, great. Thanks for inviting me. So I'm Hendrik Kolvenbach. So I co-founded a project in 2019 here in Zurich called the Autonomous River Cleaner Project. It's a student-led initiative based at ETH Zurich. And then also this year, we started a company called UpCircle Technology again, that I will also explain with the correlation briefly. So what we're working on is waste, environmental pollution, if you want, coming from municipal solid waste in this case. And yeah, it basically evolves around the challenges like how can we capture waste that otherwise is ending up in nature and the oceans ultimately. And if we get it back, how can we make it more valuable? This is where robotics comes into play with robotics arms. And then also, how can we make recycling more efficient in general? So basically by segregating material, for example, by giving it a history or so, we can increase the value of the material. So for us, this is quite important because I think as humanity, we are growing. We need products. Basically, we are generating waste. I think this is not going to change anytime soon. And the problem with most of these products is that they're meant to last quite long. For example, plastics is a very engineered solution, and it will probably be here when we are not here anymore, right? And particularly if it's leaking in the environment. If you put it in landfills, we generate methane. If we are burning it, like we do in Switzerland, we also generate carbon emissions. And if you don't do it, or it lands in the nature, for example, it lands in rivers and then it lands in the ocean, and ultimately the material itself ends up in our bodies. And personally, I think this is a quite frightening thought. And Yeah, so it's for us, it's definitely a priority because material is going to be there and we have to somehow deal with this. And so what we work in particular on is, I want to quickly go through 3 projects. So one is from the Autonomous River Cleaner project, which is about monitoring waste. So we have monitoring systems that can detect plastics and other floating material in rivers. So this is very important to showcase that we have this material in the environment, and also basically inform extended producer responsibility schemes of showing like, look, we have this river and it's quite polluted. And the information basically being the first step. Then we work on the robotic sorting of this material. So using robotic arms to segregate the material, basically to get more clean material streams that ultimately also increase the value of the material. And then with UpCircle technology, now the company, what we do is we work in recycling plants directly, because recycling plants are often running blind on the input material they have in their facility, and that leads to a lot of efficiency loss. So here we use also machine learning based methods, for example, to detect what is the material that was inside and basically help the recycling plant to make better decisions. So that's it in a nutshell. I hope it was not too long. And yeah, very, very happy to be here and excited for the discussion.
Perfect. I think Mollie, you are second.
Cool. Hi. So I'm Mollie Claypool. I'm the founder, one of the founders and CEO of Automated Architecture, or OUR for short. And what we're doing is we are a tech company using data-driven learning and generative design to build a distributed microfactory network for sustainable timber housing. And at the core of our work is a low capex robotic microfactory that gets licensed to a network of existing home builders. And essentially what we have is we have a 3-part kind of value center to our business, which is we are aiming for sustainable, affordable, or accessible and high quality homes to be built using our tech stack. And this is important because right now within the industry, you either compromise on quality, sustainability, for the sake of cost. And this is universal throughout the construction industry. So essentially what we have now is we have very low quality homes being built, and sustainable homes are completely almost out of the realm of what's possible if we operate business as usual. So what we've done is we've essentially enabled a high degree of automation across the design and manufacturing process of home building, while offering a really low capex and low threshold solution using a robotic microfactory. And this is important because it sits in direct contrast to how many home builders are operating, which is and failing in delivering homes doing, which is setting up very large, very expensive, very OpEx and CapEx heavy modular factories that don't have a high degree of automation, but essentially take what already happens in the construction industry on a site, and so it essentially puts it in a big shed. And so we've completely rethought actually the place in which design production takes place, and also the core building blocks of how we design and manufacture. So we have developed a generative design tool that captures all of the materials that we use along with their energy performance, their carbon emissions, and we can make accurate calculations on embodied and operational carbon. The homes that our microfactories can produce reach Passive House standards, and they achieve 7 times higher, more energy efficiency than a standard home, and they have 8 times lower carbon emissions than concrete and steel. And importantly, we've also reduced the use of unsustainable materials by up to 90% by shortening the amount of materials that go into a single home. The way that we've done this is that we've fundamentally rethought what makes up the parts that go into a house. So we've developed a modular timber building block that sits at the very core of the tech stack, and it can really be understood as a part designed for specifically for robotic assembly. And this again sits in contrast to how a lot of automation technologies are being applied in construction, which is applying automation to solve pre-existing problems. Instead, we've said, why don't we actually design a building system or a building block that's specifically designed for getting as much value out of a robotic cell as possible? We've developed all of the integration around the robot cell, and we've developed a cloud-based design to manufacturing software. So yeah, that's the summary, I think, of what we're doing and why we're doing it.
Perfect. So then I think, Rebecca, are you next, or am I missing someone? I think you're
Sounds
up.
about right. Can everyone hear me?
Mhm.
Great. Hi, everyone. I'm Rebecca. I am the founder and CEO of a company called Glacier. We are building AI-enabled robots to automate sortation and recycling in recycling facilities, while also delivering better traceability of the actual material that's coming through on behalf of not only these recycling operators, but also everyone else in the circular economy. So major brands, producers, governments, municipalities, et cetera. Now, one of the questions I often get asked is, does recycling actually help fight climate change? You know, the way that it does that is not obvious. And the answer is, of course, yes. Basically comes down to the resources and energy consumption needed to take an existing product and reformulate it into a new thing, let's say an aluminum can, versus having to kind of mine those resources and turn it from totally raw material into that same can. So in the case of aluminum, taking a recycled can and turning it into a new one is actually 95% less energy intensive than having to mine that bauxite and go through all of the smelting processes to make that same can. So this is absolutely a critical part of the climate solution that we're all working on. And on top of that, one of the things that's fantastic about recycling is in many regions, the infrastructure already exists. Now, there stands to be a lot of efficiency gains through applying technology like automation, but you can achieve a lot of really rapid impact compared to some other more kind of moonshot solutions, equally important, but following a different development trajectory. So within these recycling facilities, for those who haven't been in there, the process is you essentially start with a commingled pile of, you know, everything that people put in their recycling bins. And then these facilities have the daunting task of actually sorting all of that. And ideally, you'd end up with these beautiful bales of, you know, paper, plastic, aluminum cans, et cetera, that can then be sold to manufacturers to turn into new material. As you can probably imagine, given the nature of the types of things people throw away into their bins, that sortation task is incredibly difficult because the material stream is very heterogeneous, very dirty, very chaotic. You know, one example I often use is one of our customers told me that a surprisingly often item they find is hand grenades. Aside from that, you know, things like weapons, needles, knives, all kinds of stuff. So you're really dealing with a very, very unpredictable sortation stream. Now, within all of this, the specific robotic challenges we're working on are actually, I would say, primarily related to the design that we've chosen to proceed with. Now, to give you some context, automation is not totally new within the recycling space. There have been AI-enabled robots that are attempting the sortation challenge for, at this point, maybe about 5 to 7 years. So somewhat new, not entirely new. And what we noticed pretty quickly is that everyone was using some form of off-the-shelf robots from, you know, ABB or Omron or Fanuc. A lot of them were using this Delta robot design that they plopped into these recycling facilities. For those of you who have been in a facility, it is an incredibly unique environment. And so what we heard from a lot of customers was that, you know, the existing automation was not particularly reliable because it would break down very often, that it was very expensive and very space consuming for the job it was doing. And so we essentially decided to go purpose built, and we designed, integrated, you know, wrote all the firmware, software, et cetera, for our own robot. And it's been definitely a fun journey to get that thing performing at the cost targets we need it to, and at the performance targets we need it to as well.
Great. I think the next presenter, panelist would be Rob from Molg. Are you with us today? Or maybe someone else from your team?
It doesn't seem like Cara, but we are trying to reach them.
Okay. Okay. Well, maybe I could do I could start off with a question for everyone, and maybe you will have some other questions after. So I guess Hendrik, since you were the first to speak about both ARC and UpCircle, well, maybe we could start with ARC because you know, I'm wondering in terms of river cleaning and then the business model? I mean, it's obviously something. Who are you finding that are, because it's something that you need to maintain? And sorry, I don't know much about the robotics that you're using, but do you find that there's the capacity to maintain, or is it something that foundations and nonprofits have to chip in? How are you able to maintain the equipment?
Yeah, thanks for asking. And you take one of, I think, my personal most interesting questions, like how do we finance this kind of actions? Because as we have robotics that is working in like an outdoor environment in areas that are polluted, it's also the like areas in the world which are not known to have like a lot of economic like money that they can put in such a system. So it's incredibly hard to find funding for this type of activities if you want to do it on a profit side. So we have been getting so far, since there's a lot of development related work, we got money mostly from foundations and NGOs so that are supporting this effort. Because if you work with hardware, especially, like there's a huge upfront cost of developing things, obviously. We have been exploring different business models. One of it was the so-called plastic credits. So for those not familiar with this, it's basically finding a way to bring money, let's say, from a country like Switzerland to finance an operation in a different country in return for so-called plastic credits, like basically a transparent proof that material has been recovered from nature. I find the mechanism itself is quite interesting because it allows basically this transfer for this type of action, but the actual implementation so far is very lacking. There's not really clear standards here. There's a lot of potential for greenwashing. There's many issues with this. However, it's one of the very few instruments that seem to work to some extent, I found. Since legislation is still lacking in some of those countries. I mean, another option is the extended producer responsibility schemes that are becoming more and more common, but they're still at the very early stage of implementation in some of these countries where we have a lot of waste. So as long as that's not there, maybe it's a bridging instrument using plastic credits or something similar. But it is very challenging. I mean, we have not found a solution for this yet. And yeah, another point, I think Rebecca mentioned it before. I think there's not that, like in this space, like technology is necessary, but a lot of the technology already exists, and it's just a matter of finding a way to finance it properly. And yeah, funding for this type of actions is very crucial. So.
Well, there's a reason we have foundations and nonprofits, so it's good that maybe we can use this platform to spread the word about ARC. And just to say a few words also about UpCircle, are you, in terms of your clients, and are you finding, as I understand, Rebecca, maybe you're in North America predominantly, and Hendrik, you're Switzerland with me, other side of Switzerland. I'm curious how, the recycling community and, basically those companies are accepting your technology and how you can integrate it. How are they perceiving this?
Mm-hmm. Yeah, in Switzerland, so it's recycling business is very traditional industry. So it's very analog. It's heavy duty. If you've ever been in a plant, it's dirty. It's like big machines. It smells and so on. And people working there also kind of robust, let's say. And the kind of technology that we work on at the university is sometimes it's high tech. It's like in clean rooms, tested in a laboratory setting. And one of the challenges is to convince those folks that this technology actually works in their environment as well, since it is sometimes so new that for them it feels quite new. So they really want to see a proof that this actually works. And if you can provide a return on invest in like a foreseeable time, they are quite open to use it. So it's very classic. Like it has to provide a benefit. You have to show that you can do it, and then they buy it. I think there's no magic.
Okay,
yeah,
and yeah, go ahead, Rebecca. I wanted you to follow up on that to see your experience
absolutely.
too.
Yeah, so we are currently based in North America, but as Hendrik was saying, it's pretty similar here too. I'd say we founded Glacier at a good time about 4 to 5 years ago when, as some of you may recall, that was around the time China passed its national sword policy, effectively saying we've been the world's largest customer of recyclables, but the world is not doing a good enough job of sending us high quality material. So until you can improve your purity rates pretty drastically at low enough cost, we're not interested in buying any more of that stuff. And so, at least in the US, I'd say recycling, the sortation process had not fundamentally changed for many decades because there was no reason to. And that provided the backdrop for this sort of legacy industry to really think in new ways about adopting new types of innovation. One of the interesting and fun challenges for us in the past few years has been to basically help educate customers on not only the potential for technology like AI and robotics to help them, but also to give them a realistic understanding of the current state of things, as well as the technical challenges that still remain to be seen. I would say that the waste industry, maybe because it is a bit of a legacy industry, tends to be relatively risk averse. And so the idea of them being the first to embrace a lot of these rapidly developing technologies, a lot of folks are certainly a little bit hesitant at first. And so it's been an exercise in sort of coaching them on the expected results they may see in the first year versus 10 years from now, and showing, to Hendrik's point, that there's already a really strong positive ROI to adopt these robots today, and in 10 years it will only get better.
Fantastic. It's really interesting. I'm happy that the ROI is that quick. It's a very good thing to hear. And then maybe if we can ask you a question, Mollie, about it's very interesting. I mean, the buzzwords that stuck out in my head when you were speaking were about having more material efficient process, and then you can, basically promote more sustainable materials. So can you explain to me in terms of the process, because it seems like is this only for timber housing, and can it be adapted? Can you somehow adapt the technology to more, because I assume you're also based in North America. Timber is not as widely used in Europe. There's a lot more concrete. So I'm wondering, if there's anything that you can do to transcend, because there's obviously a lot of inefficiencies all around in terms of housing construction.
Yeah, so it is primarily, it's designed for a timber building system that we've developed. So it is exclusively for timber. I'm actually based in the UK, despite my North American accent.
Okay.
But we are working in the US already. We're currently working in Belgium, the UK, and the US. So we've done this strategically because we believe that at least in terms of the regulations, there's actually across Europe not too much difference across markets in terms of the timber regulations. There's actually a lot of difference in terms of the perception bias. So what we're trying to do is actually do a lot of education and bias breakdown work around the use of timber as a regenerative material in the construction industry. And I guess one of the things to say is that what we've done is we've developed, typically in a process of building a home, is essentially an assembly line process, right? You first have the structure, and then you have the first fix, and then you have the second fix, and it's very much relies upon a kind of order of operations, that one before the next, and it can get very complicated. The supply chain can get very complicated. The labor organization and logistics can get very complicated. And this is where inefficiencies appear. And what we've done is we've essentially said, why don't we design a timber block that can perform as all parts of a building structure and allow us to optimize as much as possible further parts of that process down the line? And also, in order to get the most value part completed, or the most amount of a house completed in the microfactory itself, let's create a part that can be adapted according to how it's being used. So we can do structural parts, non-structural parts, passive house standard thickness parts, partition wall size parts, which allows us to actually not have to change the manufacturing setup depending on what we're doing. So we're able to operate at a much we're able to operate across a lot more typologies, let's say, than a more standardized or traditional modular process, or even a traditional process on a construction site. And essentially what that's allowed us to do is to reduce the number of different parts that go into a building. Like in a typical house, you have 7,000 different parts. Like that's a crazy supply chain with a huge carbon impact. We actually have about 20 materials on our list of materials for a single house. And that greatly reduces the carbon impact across the entire process, holistically speaking.
This is incredibly interesting. And so how, I also think of scaling for your technology. So do you have a certain, aggregator that says, okay, we do a lot of the timber construction in a certain area, and so then that you only have to convince that one, construction group, or how is that working for scaling up?
So so what we're doing is we're right now we've honed in on 5 actually, but 3 right now, key markets that unlock greater other markets for us to work in. So Belgium is where we first have our first microfactory, and we're in Belgium because it's the toughest market in terms of regulations. So it actually allows us to unlock the rest of Western Europe quite easily if we can unlock Belgium, and we partner with our ICP for a partner is a fully integrated design build company. That also might mean that we work with companies that have very close relationships between a developer and a contractor, right? Which exists within the industry already. And essentially we license either the front end or the back end, aka the design side or the manufacturing side of our tech stack, either to one partner or to 2 partners. And what we're moving towards is a distributor model where those initial partners become hubs in a larger ecosystem that then can fuel the distribution of our technology to achieve scale.
Wonderful. Great. That's a great idea. Great. I think I'm going to leave Minghui to maybe ask more robotics focused questions, which I don't have the expertise to do. So I'll let you continue.
Thanks, Cara, and thanks all the panelists. Very inspiring discussion. So I was wondering, because I work on robotics, especially robotic arm, and I realized actually robotic arm has been extensively used in manufacturing, especially assemble, and robot can move faster with great accuracy, precision, and actually kind of reliable for those types of the manufacturing lines. However, but in different domains, for example, recycling and remanufacturing or architecture, they're not so extensively applied due to many difficulties. So based on your understanding or based on your expectations, so what the robotics should look like, or what types of the properties that you are expect to introduce robotics into your domain? So what is a major challenge, and what is your expectation? What do you hope the robotics engineer, robotic researchers can solve which issues such that you can bring it easily to your domain? Yeah, this question is to all the panelists, so feel free to unmute yourself and discuss.
I'm happy to start. I think I often refer to recycling sortation as the strangest manufacturing process on the planet, because in no other domain do you as a manufacturer have no control over the volume or quality of your inputs, right? Whereas, in recycling, of course, you don't have any say in what your communities choose to throw out and what may show up at your facility, and yet you're still expected to produce a certain level of output. And I think we've seen a massive amount of variation, even within the same facility, from day to day or at different times of the year. And so I would say, a big part of our challenge actually pertains more to how do we manage that surrounding environment. One very common variable we discuss with our customers is something we call burden depth, which is basically how much stuff is showing up on the belt. You can imagine that, if you're going after aluminum cans, but they're buried in a huge pile of material, it's going to be a lot harder to even detect it with our computer vision, much less actually have a robot go in and grab that material. But I would say, as it pertains to robotic advancements, a lot of the biggest area for opportunity, I think, is around what does that end effector look like? Right now, we use suction. We use a suction cup design, and it does a decent job. But of course, the human hand is an engineering miracle, and it has immense dexterity and speed. And we've seen that it's still a challenge to find anything that can replicate that type of successful grasping ability. And then I think the final thing for us from a robotics standpoint is just figuring out the right balance of parts that can perform and also don't wear over time. As we've all alluded to, I think, you know, the waste industry is certainly, by definition, it's pretty dirty. And so it's important to have a robotic arm that can not only sustain a certain speed and successful manipulation of items, but to be able to do that over long periods of time when, you know, maybe, for example, I've seen it going after, or robots go after dirty diapers that it's then trying to pick up and sucking who knows what into the pneumatic system. Or we've seen, you know, cans of beer go by spraying stuff everywhere, right? So how do you build a system that's robust enough to endure that type of environment over many, many years?
Yes, thanks, Rebecca. Yeah, go ahead, Hendrik.
Yeah, I think I can only second to this. I think the manipulation aspect, I think, is key. Like, and I think there's been quite some advancements over the last couple of years, also using like some of the newest developments in terms of like understanding really how to grasp objects. I mean, the human hand, but also the perception of the human, like knowing what type of item, how to best grasp an item, and quickly deploy that on unknown objects, because literally you don't know what is coming. In the river, it's even worse. There's even more material you can find. There's algae tangling with other material. So you require an enormous amount of dexterity to take these items apart and really understand what you take. And then there's the robustness aspect, exactly. Like there's large amounts of volume running 24/7. I want to add one other point, which is, I think, also not be too expensive. I've visited some recycling facilities in India, for example, where like while as in Europe, we have mechanization in the recycling facilities, pneumatic systems, robotic arms that are handling material. And in countries like, for example, India, it's still cheaper to hire people to do this work. So you are on a conveyor belt in the facility, there are like 50, 60, 70 people on the conveyor belt manually taking this material apart. And in order to have a robotic installation there, you have to basically make an argument of why it's more cost effective to use this system. So so that's where the engineering challenge lies, right? It has to be robust, it has to be versatile, it has to be also cost effective. I think these are the main aspects where we have to put more effort into.
Yeah, I mean, I can just shed light a little bit on one of the challenges that we face, which is based on what was just previously said, is that we are putting a lot of functionality into just one robot cell. So we're taking a lot of different parts of a process that it currently exists in different stages with different forms of labor into one package, and that requires quite a lot of communication and integration in the cell itself. That is a challenge, and then also it provides it essentially means that there's an extensive amount of limitations when you consider that we are very holistic in that we are designed all the way through to manufacturing. So it has limitations in terms of what's possible for design. And it also has limitations on what's possible on the other end of the spectrum when you get to the assembly portion. So I would say that that is something that for us is a constant battle, is like, what do you actually include and what do you, and is validated to include within the cell, and what are things that actually would be worth waiting further down the line to integrate.
Yeah, thanks everyone. I think I got very great feedback. For example, the manipulation, the gripper design, how to achieve the similar skill level of the human, and also the cost perspective, and also probably, as just Mollie mentioned, we probably can incorporate different types of the function to different types of robots. There's probably no need to just incorporate too much function into one single robot. There might be a good distribution among different types of robots for the coordination for different tasks as well. Well, I get very good insights from you. Thank you very much. So another question I was thinking that, suppose that those techniques is kind of, I mean, we can overcome these challenges, and we want to put to the startup companies. And we know that we consider the cost issues and a lot of issues, but I was wondering, how about the labor? So whether bring a lot of machines to startup company, to small to medium company, so in which way this will affect the labor force, the labor market in this domain? If you can provide some discussion, insights, and the feedback or something, that will be great.
I'd love to jump in on this because there's a perception in construction that robots will take away people's jobs. There's actually not the people to do the jobs. There's an increasing, the largest demographic of workers in construction are 60 plus, and the lowest number of people coming into construction is the generation that is going into the workforce. So those people don't exist. And we have a massive need, right, to build more sustainably. So that's a big opportunity for us. And what we've seen so far is that, and what we validated with our first microfactory in Belgium is that we can train people to use the robot cell in under 30 minutes. They're only needed for a third of the day to operate the cell, which means that we can diversify people's jobs. We can retrain people into new parts of work or new forms of work. And we can also create an opportunity to move people out of a dirty, dangerous, and dull job to one that is much more aligned with like a good, healthy place of work, which doesn't exist when you're on site in construction. So what we're calculating currently is that one robot cell can save potentially up to 60% of labor costs for the build of one house. At a kind of minimum, it's 20%, which is significant when labor costs are in between 40 and 60%, depending on the market, in relationship to the overall cost of a house.
Thank you. Anyone else want to jump in and share some insights from your domain?
I think I can only again say the same thing for the recycling industry, which the example I just mentioned on the conveyor belt with like 50, 60 people in this dangerous, dirty work environment. I think if we can help those people by providing better jobs, by working with the robots, I mean, maintaining robotic systems, for example, is one of them. I think this is way more in line with what a good job would look like. So I think it's the same in recycling.
Yeah, totally agree. I think it's not worth continuing to belabor the point on my end, but we see the same thing in the North American recycling and waste industry as well. So the robots are basically taking over a critical role that other people don't seem to be stepping in to fill.
Yes, thank you. That will be great because there was a concern that whether robot takes too much jobs from human, but based on your feedback, I feel that actually it's not. Actually, robot is help with this domain and create more comfortable jobs and more diverse. So that's good. That's great. So I have another question. So introduce robots, and sometimes we may need also introduce human robot collaboration just because that partially because that robotics function is not as so high level. Sometimes it needs humans guidance, it needs collaboration with humans, and this will cause some safety issue in human robot collaboration, and those safety issues will introduce some safety standard or something like this. So I was wondering whether human robot collaboration in your domain might be a short-term solution. For example, we cannot totally cage robot to do something by themselves. We still need human supervision. So in this case, so if that's the short-term solution for your company, for your startup, so I was wondering, how will you address the safety? There must be some safety standard, but whether safety is a big concern if you're going to introduce human robot collaboration, and how do you want to overcome this besides the technical technology perspective? So will you make some policies or think about strategies to make sure that your employee, your workers feel safe when they're trying to work with humans? So how do you handle this kind of build the confidence of workers when they work closely with robots or machines?
I mean, we have extensive safety things put into place. So, I mean, the image in my background is not true to life. Like there would need to be a guard entirely around this for this to actually work in real life. But I mean, these are industry standards, like to put around industrial robots, to put caging or sensors or anything like that. And that's been done in the automobile industry and manufacturing industry for many years. And so we're, mimicking that as much as possible. It is for us, because we are inherently across multiple markets at once, interesting as a project to look at where those safety standards differentiate. And that's just a process that we have to do on a local basis as we enter new markets.
Yeah, similarly here, I think safety is paramount for all of these facilities, and there's some pretty well-established guidelines on how you can ensure the safety of any sort of industrial equipment. So those are the guidelines we follow as well. Our robots do, interact quite a bit with human workers, whether it's sorters who are standing next to the robot effectively picking items as the robot would, or certainly as well teaching the on-site maintenance teams at these sites to be able to maintain and repair the robots as well. So because our system is sort of our own design, we've had a lot of ability to control what goes into those trainings and those development programs for these workers so that they best understand how to interact with this type of hardware and how best to maintain it while still keeping themselves safe.
Yeah, in the RiverClean project, we work with collaborative robots because there are different ways we can make safe areas according to the machine directive. One is the caging, depending on if objects can be thrown. The other thing is do it by a certain process. You're not allowed to enter a certain area when the machine is active, or using light curtains, for example. But as long as you're according to the directives, I think there's not a big problem there.
Thank you, everyone. Yes, we have some safety standards, and I think from my perspective, I also do some research for human-robot collaboration. I think it takes some time for my students to build some confidence, even after they do a lot of training, safety training, and know a lot of algorithm robot works. It still needs them to build some confidence when they work with the collaborative robot to see, okay, that's safe to me, and it can avoid some collision, and I have time to respond quickly. So yeah, so that's actually probably one of the most important directions that we should consider in the future when there are a lot of robots moving to the companies. Okay, so another question, probably my last question for the general panelists is that after that we will open discussion from the audience. So before that, I was wondering, do you have something that you want to let the policymakers know or hope that they can make some policies or encourage something such that can help you to facilitate the procedure, the automation levels in your startup? So do you have something that you want to share?
I think in our space, and particularly in North America, there's been a lot of landmark legislation in the past 5 years or so around recycling and waste processes. And I know that, sustainability and extended producer responsibility is becoming increasingly important and talked about. I would say for the policymakers that are involved in our sector, when I interact with them, a lot of them don't necessarily even realize that this type of technology is available yet. And so some of that is even just making them aware of, the fact that it exists, what it's good for, and how you might be able to use policy to help encourage more rapid adoption by the industry to help meet some of these really stringent requirements that are starting to take effect as early as 2025. And so we've seen a little bit of that where, I've heard examples of major US cities that have maybe written into their request for quotes from different waste vendors that they want to see a certain level of investment in modernization of their facilities or adoption of new technologies. And of course, that's a huge carrot for all of these potential vendors to then go out and understand how to actually adopt that technology. So we're starting to see a little bit of that, but I think even more would be definitely very helpful.
What's interesting in construction is that in 2022, there was a new policy built into the UK building regulations around sustainable net zero building, which says that all new buildings need to be built to sustainable standards, which means that construction companies that don't start adopting an approach that can leverage automation to achieve the sustainability standards are going to go out of business because they will not get the bids anymore. So we're at the cusp of seeing a rapid change in the industry over the next 5 to 10 years. And we're already seeing it happen in the failure of businesses which have had such high CapEx and OpEx investments fail. In the UK, there's been some monstrous failures in the last 2 years, and even in the US as well, like Cara and others that have demonstrated that it's not possible to have that level of investment that you would traditionally see in a huge factory to deliver on sustainability standards and needs. So we're going to see it happen. It's already happened in the regulatory environment. You can see it elsewhere in the EU as well. In France, it's all new. Buildings have to be built out of timber, for example. So there's a lot of things that are shifting at the moment towards enabling the adoption at a rapid pace.
I also think that schemes like extended producer responsibilities also that find ways to increase, let's say, the monetary inflow into the recycling sector, I think is important. Also, these technologies that we have, as Rebecca mentioned, for example, now we can see brands entering a plant, right? So we can at scale say how many Coca-Cola bottles have been found in this recycling plant. And we can use this information, right, to drive EPR schemes and say, like, look, we have found that many bottles, maybe you should contribute to the cleanup of these materials. And then really make it a law and make it come fast. I think that's the one thing. I think a lot of the things are here. Yeah, there has to be some education as well to show them what is possible, and also pull in the companies that are also producing material and really make it things tangible. So really make sure that this will get established, because obviously, besides the pledges of companies, in the end, what matters is what has actually happened. So, I mean, we have seen also things where companies do a pledge, but when it comes to actually funding stuff, then that goes away because it's on the marketing budget and you're not really on the core business. So, yeah, it has to, policymakers have to put these things into action quick.
Yeah, thank you very much for sharing this feedback suggestions to the policymakers, and hopefully they can hear from us. So I'm going to open up the questions from the audience, and so everyone, if you have any question, because we are not a big room, so feel free to either type your questions in the chat, then I will read that question, or feel free to directly unmute yourself and ask this in a more interactive way. It looks like we already have I will first go with the question in the chat, and then Berka will go with you. So the first question is, how many ineffector robots do you use to do the job? I mean, so in the river cleanup and the AOAR Glacier use cases. So yeah, feel free to share. So how do you think that, I mean, I want to add on. So what types of the ineffector that you think is more effective in addition to this question? Yeah.
Yeah, I can go first because we put a lot of effort in the development here. So we used very standard 6-7 DOF robotic arms. We experimented with a lot of ineffectors because riverways is very diverse, like very different types of objects. And in the end, what we work with is mostly a 2-finger gripper, where we modify also the contact surfaces. We have here a commercial product from Robotics that we use and then adapted. And then also we use suction cups, so vacuum suction cups, which are actually quite nice when you have rather flat surfaces, like think about cardboard, for example. Yeah, that works quite well. And if you have more arbitrarily shaped objects, then really 2-finger grippers or things like this really work much better. We also developed some things custom in-house just to see if we can make it more robust, like a waterproof 2-finger gripper, something like this. On the research side, I will share the link of some of the things that we have been looking into. And if you have more particular questions, feel free to reach out.
Thank you. Anyone else want to respond to this question as well? Rebecca, Mollie?
Yeah, I can shed some light. So I mean, we have one end effector that does all the jobs. It also has a tool changer attached to it, so it can change tools. And again, as I said earlier, you know, we're trying to integrate a couple of different processes into that cell. So we also have developed all the integration around the robot, you know, the onloading and offloading and all of the other kinds of vacuum beds, et cetera, like that, that we need to do assembly on. But again, that's more about the integration than it is about the end of the robotic arm itself.
Yeah, as Hendrik mentioned, we also use suction cups primarily. And, you know, we actually in our office, we have a wall of cups, which shows a couple dozen of the different iterations we've gone through to get to what we're currently using, because we're trying to balance, you know, the robustness of the cup and the desire to not have to change it, you know, every couple of hours, with the fact that it also needs to be kind of malleable enough to pick up a wide variety of different recyclable items in these facilities. And then to answer the question in the chat, we currently would say that one of our robotic cells is roughly comparable with what a person could be doing in terms of the picking speed and the general accuracy there. So to the ROI conversation earlier, we're already seeing that that's certainly very compelling to have a much lower cost robot that can effectively complement where you would have had a person doing that job a few years ago. And then as we move forward, of course, we are not only increasing the ability of each robotic arm to pick more, to pick faster, et cetera, but we've also built a fairly modular design. So the thinking here is, given a certain amount of space, we can right size that robot to put in, you know, however many cells in a pretty compact amount of room to pick whatever the volume of materials is that may be needed there.
Great, thank you. I hope this question is answered. It's pretty interesting to me. I think also the Graper design is pretty challenge. Not only design, but also in real time, how to move, how to control this robotic hand to let it grasping and do some manipulation. That's also very challenge control problems in my domain. Okay, so let us move to the next question, Bert. I think you raised your hand just now, so do you have any questions?
I do, but Cara, would you like to go first?
Well, it's a question. I was just thinking of a common thing, which I'm wondering how it's impacting. I hope it's already making a big difference in all of the technologies today, because you just see that in the case of heavy metal or, you know, precious metals. There's a, you know, there is already a shortage of supplies. And so I'm wondering if, you know, in terms of recycling, if you already see that in terms of supply shortages. And of course, Mollie, this is for you. I mean, I know that, yeah, even for our house, we had an issue with getting simple wood. So I'm wondering, do you see that this is impacting you when we just talk about supply shortages, not only maybe the resources, but just getting the resources from A to B, and that you have to do something more local or just to save it locally?
I mean, in terms of the robotics setup, so we have a strategic partnership with ABB, and we were one of their first, well, we were their only construction tech investment in their new robotics ventures group. So we've had a strategic partnership with them since 2021. So in terms of being able to access robots, we're in a pretty decent position. We're also, if we think about the scale of our project, scale right now is 300 robot cells by 2030, and that has the capacity of producing over 75,000 homes a year. So that would make us one of the largest house builders in the world, collectively as an ecosystem. So like somehow I think there's this perception that actually we need like thousands and thousands of robots. Actually, as we get better and better at optimizing the use of those robots, we'll increase our capacity, and therefore we won't necessarily need to run into those problems around supply chain, which will inherently exist. And we know also that those arms last, you know, 20 to 30 years in some cases. So we also know the amortization of them over time is pretty valuable. And then in terms of the timber, so we have developed an approach that allows us to use local timber. which means that we can have a strategic relationship with some large suppliers if we have a larger pipeline coming through that ecosystem, or we can actually work with local timber. And we have a diverse, we have a few different compositions of timber that we can work with that allows us to circumvent those supply chain issues. And the timber crisis that happened in 2021 is probably a once in a lifetime event. And the timber prices are now starting to level off, which means the supply chain is opening up. So again, it's, you know, it's being able to think about not just a kind of how do we protect a global supply chain, but also how do we diversify in the design stage so that we can actually be able to work with localized products. And some of our partners are working with organizations like Forestry England, which are really looking at how do we build forests that can supply the amount of timber that are needed for projects like ours.
Great, thank you. I'm not sure if anyone else has, you know, Hendrik or Rebecca, I'm not sure if there's anything that you've seen people say to you, where can you give us a supply of X material? Yeah, I'm just curious how that's working.
Yeah, maybe one thing that comes into my mind is the use of so-called ocean-bound plastic. So let's say material recovered from the river or the ocean has a certain extra value, let's say, which is quite interesting, frankly. If I would get, let's say, some PET bottles here, they have a certain material value. In Switzerland, for example, it's even special because there's a subsidization system, so processing of this material is even co-funded, let's say. But if this material comes from the ocean or was extracted from the ocean, some manufacturers are interested in this particular stream because they can use it for their products and then claim that the product has been used from material that has been recovered from nature. So there's an additional, let's say, artificial value attached to this material that can be used to co-found activities there. And that was something that I found personally quite interesting because it's just, there's still the same material, but let's say the way it was collected was priced in the material value. And I think if you can have a complete chain and traceability of that this is actually has been the case. So let's say there's technology that allows you to trace it somehow. Then there's money attached to this. So and that was curious to me.
Very interesting. Rebecca, are you with us?
I think she has to drop off due to another appointment. Yeah.
Okay, no worries. Wonderful. Well, I don't have any other questions. I'll let the audience.
Thank you. Berg, do you want to raise your question?
Sure, thank you very much. I was wondering if the market is pushing you towards fully autonomous systems and no human labor, or is it, or are you seeking for human-robot collaboration, or are you designing robots particularly for human-robot collaboration in mind? The reason I'm asking this is, for example, in the waste space, recycling space, the problem is so difficult that it becomes really, really challenging to go fully autonomous. But when you go to customers, which is like waste sorting facilities, they all are really looking forward to having a fully autonomous plant. But at the same time, so that's what the solution that they have in mind. So I guess what I'm trying to say is that there could be great opportunities if it is allowed to have that collaboration, and then maybe even better environmental outcomes coming from that and enhancing the capabilities of the overall process. But maybe it's not possible with the constraints that you have coming from your customers, coming from various other reasons. Thank you.
So I think when we talk about, so what we do at UpCircle, which is a lot about monitoring, not even actively changing things, but what we do is we inform people that work in the plant to make better decisions. So in that sense, it's collaborative, but maybe not in the classical collaborative robot way, because In order to give the workers this type of knowledge, you literally need a system that 24/7 watches what is happening on a conveyor belt and look at it with superhuman eyes and provide data insights that no human can provide. But then in order to change something in the process, you have to, let's say, minimize the amount of information density to something that is digestible by a human and give him that information. And that human can then make a tiny little change in the process that ultimately leads to a large reduction in costs for the recycling plant. So I think there's a big chance for this type of collaboration where maybe when we think about it, it's not like an arm or like a human doing something on the belt, but it's more like, okay, there's a system that gives you information, and then you as a human can still act on it like you were doing before, but now with way more information and knowledge than before. So I think that's maybe just the one thought aspect for how collaboration could look like, other than like an arm next to a human.
Thank you very much. And I guess, Mollie, if in your case, I guess it is a little bit more, you had the opportunity to be able to redesign the system from scratch without sticking to traditional ways of doing that building process. So I guess it's less of a problem and you can go more towards full automated systems, I suppose. But do you have human robot collaboration in mind?
I mean, so what we've done is we've automated the most high value part of the process. And what we like to say is that actually where our innovation lies is in that connection between the building block and the manufacturing. But when it goes together into a building, it looks, acts, and speaks like a timber frame building. Like, it's not unfamiliar to any other part of the process. And that's very, very important for adoption, not just in terms of regulation, but in terms of all the other bits that have to go into a building. And so we've made that really conscientious decision to not work on creating a new kind of building material that has to enter the market through a very difficult regulatory path, and instead say it looks, acts, and speaks timber frame, and therefore it is. So you guys know what to do with it. There is potential for more collaborative robotics further down in the production line, for example, in the connections between blocks. But right now, that is not faster or more accurate than doing it by hand with one person in a microfactory. So the robot can help with certain aspects of that, like laying out the blocks in the right order and in the right position. But in terms of the actual act of connecting them together, it's not really high value enough right now, and probably won't be for a long time.
Thank you very much, both.
Thank you. I think we have another question in the chat box. I believe this question is to both Mollie and Hendrik. So, are the robots using camera or sensor technology? Why did you choose this technology for your solution? What are the main challenges and obstacles in implementing robotic solutions for recycling, for the recycling on a large scale, and how can they be addressed?
Yeah, I can start with the first part, maybe on the technology. We try different types of sensors. So when we look at, for example, the material sorting on the RiverClean waste, we use an actual detection box. Before we have the robot that has a depth camera inside, but also just a normal camera to get a picture. And we need the depth information to predict the grasp handle. So how are we going to grasp the object most cleverly? Challenges here are that some material is transparent, for example, plastic bottles. So some systems won't work, like lighters, for example, because they just go through with laser. So you have to be a bit smart, like considering the type of material that comes, and you select an appropriate sensing system. Now we also work on maybe attached to this, we talked about the gripper, we talked about the sensing, we can also talk about the control, like how do we come up with an optimal way to grasp an object. And I think what is quite powerful here is the use of reinforcement learning technologies, where basically in a simulation environment, you train robotic agents on various types of material. I think this is a technology that also just came properly into existence a few years ago and allows you to be way more generalistic when it comes to grasping heterogeneous material. So other than the sensing part, I think the control aspect of it's also like super important. And then maybe regards to the last questions about what is required to do at a large scale. I think we are actually working on that in terms of like making the technology more robust, demonstrating that it can provide a benefit, that it can generate a return on invest. At the same time, trying to make it cheap, make it more robust, more sustainable to use in the long run. Educating the industry that this is there, educating regulators to tell like what is required and what is possible with the technology. I think it's a very multidimensional aspect in my eyes. So, but I think the industry is moving, so it's a good sign.
So we have a slightly different approach in that we accommodate for material variability in the programming of the robot itself. So we can have like real-time adaptation depending on what it's grasping, but that's the extent of the sensoring technologies that we're embedding in the cell, primarily because we want to keep the CapEx as low as possible for ease of adoption. And that means that we are seeing other companies in the market actually who I would say are primarily from a robotics background actually are putting a lot of emphasis on camera and machine vision in the cell. But I suspect that they will be so expensive when they go to market that they won't enable adoption at the scale that we need. And this is I would say part of it's a core value that's embedded in what we're doing, is that we want to keep the cost down so that we can enable adoption at scale as fast as possible. And that means that maybe some of the things that you would think might be part of the cell itself are things that we don't actually see as high value enough integrations at this point in time to enable that to happen.
Yeah, thank you. That's a very good point. I hope this answered this question. It's well answered, Lai. That's okay. So, we probably have time for another 1 or 2 questions. So, any additional question? If I remember correctly, Carmel, did you raise your hand just now, or? Okay, never mind. So, any additional question from the audience?
Yeah, I mean, if there are more questions, also we can connect on LinkedIn or write an email. Also, I think this is also fine.
Maybe we can go to hot takes, a couple sentences of hot takes from the session.
Right. Maybe I'm not sure if everyone knows. I mean, if you haven't been following, but basically what a hot take is. But we wanted to get from you more of your ideas of, you know, I guess, well, I guess we have some last questions for you. So we had, you know, how can the broader climate robotics community support you? Are you hiring? Are you looking to launch projects in other countries? Are you seeking funding? So it's kind of a generic question, but most importantly, and it's Patrick's favorite thing to do is to have a hot take, which is basically a provocative point of view, something that is not, it's a view that's not shared by most. So you can respond to all or any of those questions as the last questions, and I'll put them here in the chat so you could see which one you might want to respond to. For Hendrik and Mollie.
Yeah, I can go first. I already put a link. We are hiring. We have however, just completed our round of robotics hires for the year, but we might be adding another one to the team. So if people are interested, then obviously take a look out. I put a link in the chat. We are also launching, we've launched in the US, we'll be operational in the US this year. And we're currently in validated lead conversations in 4 other markets besides the US. So that's very exciting. Key markets for us are the Netherlands, the Nordics, generally speaking, and Portugal, France, and Spain. So very cool, I guess, for us at this moment to be at least in 3 markets and looking to open in others. And then we just announced a seed round that closed a while ago, and we'll be raising a Series A in Q1 2025. So watch this space. And then my hot take, I mean, I think I've said a few of them already, which is that, there's this idea in construction, because it is very much an industry that hasn't changed for like 150 years, that robots are taking jobs. And we're amongst like-minded people here, but if you were in a conference in construction, you would be seeing people like absolutely shocked that, the problem isn't the robots. The problem is that the industry itself doesn't have the labor available because it's not talking to a younger generation. So maybe that's my hot take, that, at least in my industry, people would be like, bye.
Yeah, maybe from our side. So we'll also open some positions rather soon. So I just posted here the link. We will announce them on LinkedIn. If you're interested, follow us and then stay up to date whenever we are opening positions. We are hoping to get the best talent, obviously. Then from, let's say, for my hot take side, I think like really everything has to become more tangible. There's a lot of talk about the space in recycling. I can say that everybody wants to do something and so on, but there's a lot of talking and sometimes very little action. And I think some of these people that have been talking about it, I really wonder if they've ever been in a recycling facility and see how the industry actually looks like. And I would really hope to see more people in recycling facilities and really try to find ways to improve this industry, because there's huge potential for sure. I mean, there's so much waste being produced. It's such a pressing need. At the same time, it's a very traditional industry. Like there's huge opportunities for that. And if you can move some of the talking space to the making space and be quick, I think there's a lot of benefits to and opportunities here.
Fantastic. I guess we have a final closing. Minghui, do you want to start with that?
Yeah, I just want to thank all the panelists and audience, and especially our panelists to share great feedback and the problem that we need to solve from engineering perspective, from the policymakers, I think increase the automation capacity is actually need integrated efforts from everyone, from the researchers, engineers, companies, laborers, workers, policies makers, and also some funding agency for sure as well. Thank you. And so we have tomorrow. I think tomorrow we also have the plenary discussions, and we're going to gather all the information in parallel. We have 4 parallel discussions, so we're going to gather all the key perspectives there and discuss and share. So if you have time, please join us. Thank you.
Yes, and what we've been doing, just so you know, is we've been taking notes, and maybe Burke, you can say, but I think the notes will be shared with everyone, but basically compiling what we've done in our session and the other sessions so that they can be visible for everyone.
Exactly, and notes and recordings we are hoping to share with the general community and try to grow this network as much as possible, so that whether it is hiring or funding or collaborators or customers, whoever we are seeking for, we can find it much more easily. So yeah, thank you so much, everyone.